Good morning, Algebra 2. So, today we're going to cover 22 and 23. 22 is pretty simple. It's on discrete and continuous functions, and we're going to practice what domain and range looks like. So let's first start with defining our functions, and then we'll do one of each. So the first term is continuous. So a continuous function has no gaps, no holes. I would be able to draw the graph without picking up my pencil. Okay, so it's a continuous line. Examples. Okay, an example would be a linear graph, right? If this was y and this was x, notice this is a continuous line. There's no holes, there's no gaps. Another example, here's x, here's y, would be like a quadratic function. It's a smooth curve. I could draw this without picking up my pencil. Now, graphs are going to take all shapes and sizes, right? Here's a cubic function. Okay, that is a continuous function. There are no holes, there are no gaps. It's one smooth line. Then there is discontinuous. Discontinuous means there has holes, gaps, there's a break in the line. There's obvious gaps and holes. Like you would have to pick up your pencil when drawing. So examples would be, this is x and this is y. I'd have this beautiful function, but with a hole in it. That is discontinuous. Okay, you would literally have to skip over that to draw. There would be a hole. Another example is our rational functions. If this is x and this is y, any graph that has two separate areas, so if I had a part of the graph here and a part of the graph there, I would say that that is discontinuous. There are two separate graphs occurring. And then another one would be an example of a step function. So if I had from one point to the other, it might still be a function, but it definitely has some gaps and holes, and it's not one smooth line. Okay? Now, the last vocabulary is the word discrete. So a discrete function is where you have separate and disconnected, meaning they're not connected points. Okay, I'm only going to do one example because I can do two, but it's pretty clear. It almost looks like a scatter plot. So discrete is when I just have unconnected. So remember, disconnected means not connected. That's what the word dis infers. So not connected dots. Okay, so I'm going to do a couple examples with you where we have to identify. Okay, so we're going to label as either continuous, discontinuous, or discrete. And I'm going to practice doing domain and range. So here's this first example. If you guys were here, I would pass these out. And we're going to talk about example number 1. Okay, well, looking at example number 1, I would say that it is continuous There are no holes and no gaps. Those are just points that I use to graph, but there's no hole. There's no gap. Okay, and it passes the vertical line test, so this is a function. Okay, my domain, notice if I'm looking at x, these lines point, this points to the left, so it would move on and on and on and on to the left, which is all my negative numbers. This arrow points to the right, so it would move on and on and on for all my positive numbers. So I would say domain is all real numbers. Range, okay, now I'm looking at, remember, domain is your x values. Okay, range is my y value. So if I look at my y-axis, here's the bottom, and then the top is pointing up. So I should clarify I'm using green for domain, or sorry, green for range, yellow for domain. So range, notice that smallest number right there is y equals 0. That's where the origin's at. And then all of my other y values are above it. So I would say y is greater than 0, but because there's a point at 0, it's also equal to. Okay, next one. All right, check this one out. There is a hole. So I would say this is a discontinuous. It passes the vertical line test, so it still is a function. So this is a discontinuous function because of that hole. So now when we go to state domain and range, I'm going to put domain in yellow, and I'm going to put range in green. Okay, I'm going to erase that comma. All right, so let's talk about domain. So if I look at my x-axis, again, my graph is pointing to the left and pointing to the right. Those arrows mean that they're going to go on forever. So I would say that my domain, again, is all real numbers, except where that hole is. That hole, the x value is 5. And so here, let me rewrite this. So if you're using my notes, there is a hole at 5, comma, the y value is 4. Here's your x value, here's your y value. So because there is a hole, x cannot equal, well, I should say except all real numbers except x equals 4. X cannot equal 4, so I would put that, I would list that in there. Another way to write it is x cannot equal 4 because 4, oh, sorry, that should be 5. My bad. It cannot equal 5 because 5 is where there is a hole for x. So range. Range, I'm now looking at my y values, and I notice there is a hole where y equals 4. Now, I also notice that my y values start right here. There are no y values above 4, so y is what? Then 4. Y is below 4, so y is less than 4. But notice y cannot equal 4 because that's where the hole is. Okay? All right, moving on to number 3. Now notice 3 are disconnected points. So I would say this is a discrete function. Okay? Now in order to find domain and range, you need to list your points. So this point here is at -2, 3. The next point is at x is 0, y is 2. The next point is at 2, 1. And this last point is at 4, 0. So my domain should be my x values, right? So domain is -2, 0, 2, 4. But I know that because I'm looking at my coordinates and I'm writing down the x values. My range is my y values. So in this case, my range is 3, 2, 1, 0. Okay, so let's jump into our lesson practice, which is on page 158 and 159. So lesson practice is on pages 158 through 159. All right, and let's jump into part A. Part A says to graph and state the domain and range. So we're going to do that. I'm going to graph my points, and let's see here. I'm going to go by 2, so I didn't really need to make it that big. Not bad. Okay, so I got 4, 8, 2, 4, 6, 8. All right, so the points they gave me were, if you have your book in front of you, they gave me 0, 0. They gave me 2, 3. They gave me negative, my bad. They gave me negative 4, 6, and 9. Remember, this is, I went by 2, 9, 10. So there are my 4 points. So domain should be my x values. So I'm going to just list it from the book, 0, 2, negative 4, and 9. Okay, and range should be my y values. So I see 0, 3, 6, and 10. Part B, graph and state the domain and range of the continuous function h of x equals 5. So they're saying that y always equals 5. So here's how I would graph that. Okay, so here's 2, 4, 6. Now this is saying that the y always equals 5. So no matter what x equals, y always equals 5. So notice I'm up here on the y-axis at 5 because that is what this function is stating. So my domain, look at your x-axis. Here's my x-axis here. These arrows pointing to the left and right means the x is equaling all real numbers. And my range, y always equals 5. So y equals 5. Next one, they're showing us a graph, and we're determining whether it's continuous, discontinuous, or discrete. So this is, I don't know if you noticed, there is a hole. So this is discontinuous. And where it's discontinuous is x, if you look at the graph, x cannot equal 4. Okay. And next, part D. Looking at D, it is continuous. It is a one smooth line. E is discrete, which automatically means that it's discontinuous. So I just had to put discrete. And I don't have to name the points of discontinuity. So it's a discrete function. F is, if I look at it, F is continuous, but it is not a function because it doesn't pass the vertical line test. Okay, and we're going to state domain. Domain for F, notice x starts at 0, and it equals 0 because there's a point at 0, and all the numbers point to the right, so greater than. My range is all reals. G If you look at G, it's discontinuous. And now I have to start domain and range. My domain, if you look at the x-axis, starts at 0 and goes to 4. Remember, domain is x-axis. So on part G, notice it starts, where's my finger? Starts here at 0, and it goes all the way to 4, because we're just looking at my x-axis. Now don't worry, my pen erases, but that's where I'm getting, and it's a closed dot at 0, but it is a open dot at 4. So open dots mean it cannot equal, but a closed dot does. So notice X is in the middle for those points. Now let's look at Y, what it's in between. So on part G, Y is going from 0 all the way up to 2. Notice there's a closed dot at 0 and there's a closed dot at Y. So I would say that Y is between 0 and 2, and it had a closed dot on each one. Because both of them were closed, Y simply equals 0 and 2. Sorry, that's a hard one. H is discrete because it's a bunch of disconnected dots. Your domain, you could pause and try it. Your domain is your x values, -2, 0, 1, and 6. And range is 0, 3, 5, and 7. And that is it for that lesson.